Okay, so here's my polar equation graphs mind map. Focusing in on rose curves. They look different because they're so-called petals, which are these, look different depending on the equation. Mathematically, they're different based on their trig functions. So this one is sine, which makes the graph look different from cosine. For this example, when r is less than or equal to sine a over b theta, and a equals 5, that shows the amount of circles there would be, and b, again, controls how wide the circles are. So that's why they would be about medium size. Okay, so showing our example on the mind map, this is what it would look like showing the circles. And so you can see how A affects the graph. It determines the amount of circles there are and what they look like. So let's set it back to our normal equation. And then B will make the circles either thinner as it gets lower or thicker as it goes up, like the original example we had. Then moving on to the limit cones. Cosine graphs have a loop, as you can see here, and then sine graphs just have a little indent. So that's how they are visually different. And mathematically, again, cosine will obviously have cosine in its equation, and same for sine. A controls how big the inner loop is, and B controls which side the circle is on the graph and how big the circle itself is. So for example, when A equals 2, the inner circle is going to look something like that, and when B is 4, and it's positive, so it's going to be on the right side of the graph, we have R set to A plus B times cosine theta. A, again, will control the inner loop. See, it makes the inner loop bigger or smaller as we change it. And B will control which side and how big the outer loop is. So if I were to go to a negative number, the circle would just flip to the left side, just like that. And then moving on to circles, which are probably the most simple of them all, but they look basically the same, except they're positioned in different areas on the graph. So A is what controls and moves the center either right or left, and then B moves the center up and down. So for this specific example, the center would be 2, 4. And this graph has a symmetry of theta equals pi over 2, because if you were to replace r comma theta with negative r comma negative theta, or with r comma pi minus theta, you would end up getting the same equation. And last, for circles, again, if we change r, that is the radius of the circle, and A will bring it right or left, and B will bring it up or down.